Here we're going to talk about factoring trinomials. Now, tri means we have three terms. So if you look at these, we have 1, 2, 3 terms. All right, now, whenever your leading coefficient, so that's really your number in front of your first term here, whenever that's a 1, what we want to do is we want to set up two sets of parentheses, and since x times x gives us x squared, this first term right here, we're going to put an x in the first spot in each parenthesis, and then we're going to just come up with two numbers that add to give us this middle term, and that multiply to give us this last term. Okay, now, you may say to yourself, well, if two numbers multiply to a negative, it means that one of them has to be positive and one of them has to be negative. So if you prefer to put those in right off the bat, you can do that. All right, now off to the side, I'm just going to make a list of all the numbers that multiply to negative 28. Okay, so we could have negative 1 and positive 28, or positive 1 and negative 28. All right, 2 also divides evenly into it, so we could have negative 2 and positive 14, or positive 2 and negative 14. All right, 3 does not divide evenly into it, 4 does, so we could have negative 4 and positive 7, or positive 4 and negative 7. All right, 5 does not divide evenly into it, either does 6, and then that brings us back to 7, which we already have on our list here. So now we just want to look at these pairs of numbers and say, well, out of these pairs, which ones add to negative 3? So this pair right here, 4 and negative 7. So what I'm going to do is I'm going to put the 4 with the positive and the 7 with the negative, and that's it. That is factored. Now, if you want to check, it's really easy to check. What you can do is you can just multiply out your two factors. Okay, you could double distribute, and that should leave you with, it should bring you back to the original problem. So if we double distribute, x times x is x squared, x times negative 7 is negative 7x, 4 times x is 4x, and 4 times negative 7 is negative 28. And if you combine your like terms here in the middle, they combine to give us a negative 3x. So we have x squared minus 3x minus 28, which if you look here was the original problem. So this was factored correctly. All right, let's look at number 5. Now, if we look at number 5, again, we have a 1 as our leading coefficient. Okay, we have a 1 in front of our first term. So I'm going to set up two sets of parentheses. Now, in this case, we have an x to the 4th instead of an x squared. But that's okay. We know that x squared times x squared gives us x to the 4th. So we could just put an x squared in the first spot in each parenthesis. And from here, we're going to do the same thing. We're going to come up with two numbers that add to 5 and that multiply to negative 14. Oh, I kind of covered that sign when I was circling it. All right, so if you want to, again, you can do this off to the side if you want. You don't have to. If you want to come up with two numbers that multiply to negative 14, well, if they multiply to a negative, again, we know one has to be positive and one has to be negative. So we could have negative 1 and positive 14, or we could have positive 1 and negative 14. All right, 2 divides evenly into it, so we could have negative 2 and positive 7, or positive 2 and negative 7. 3 does not divide evenly into it, either does 4, either does 5, either does 6, and then that brings us back to 7, so we know we're done here. All right, now out of these, the pair of numbers that adds to 5 would be this pair right here, negative 2 and positive 7. So I'm going to put the 7 with the positive sign and the 2 with the negative sign. And there you go. That is factored for you. Now, you may be saying to yourself, yeah, but what about that x squared that's right there? Well, think about it. If you were to take your answer and multiply it out, x squared times x squared is x to the 4th, right, which gives us that first term. If we combine, so x squared times negative 2 is negative 2x squared. And if we combine that with our positive 7x squared, we get positive 5x squared. That's where that x squared comes into play. And then 7 times negative 2 is negative 14. So this checks out. Okay, so now you can flip to number 12 in your packet. Now, if you notice, this one looks a little different right off the bat because our leading coefficient is not a positive 1. It's a negative 2. But if you recall, our first step in any factoring problem is to factor out the greatest common factor. So if we look at what all these terms have in common, we could factor out a 2 as well as an a. Now, the only thing I want to recommend is if you have a negative in front of your first term, instead of factoring out a positive 2a, I would factor out a negative 2a. So let's factor out a negative 2a. And when we do, in parentheses, we're going to be left with a squared. And then negative 14a squared divided by negative 2a would be positive 7a. And then 60a divided by negative 2a would be negative 30. Okay, so once we factor out a greatest common factor, we want to say, well, can we factor further? Well, we have a trinomial, right, 3 terms, whose leading coefficient is a 1. So when that happens, let's open up 2 sets of parentheses right underneath that. And this negative 2a in the beginning, we could just bring that right down. Okay, we don't want to forget about that because that's also included in our factors. So here, if we want to come up with what times what gives us a squared? A times a. So we're going to put an a in the first spot in each parenthesis. And then we want to come up with 2 numbers that add to 7. So I'm going to just put an a on top of this. And that multiply to negative 30. Now again, if you want to make a list off to the side, you totally can. At this point, I'm just going to kind of jump right into it. But first of all, if it multiplies to a negative, we know we have to have a positive and a negative. Right? A positive times a negative gives us a negative. And then 2 numbers that multiply to negative 30 and add to positive 7 would be positive 10 and negative 3. So I'm going to put the 10 by the positive sign and the 3 by the negative sign. This right here would be completely factored. Okay, so our factors are negative 2, a plus 10, and a minus 3. That's what all multiplies together to give us our original expression. Okay, and then we're going to end off on number 13 in the packet. Now, number 13, what you'll notice is this is not in standard form. If you want to, have this in standard form, your term with the biggest exponent should come first, and then you want to have them, written so the exponents go in descending order. So let's do that. Let's first rewrite this in standard form. So I'm going to bring down my negative 3x cubed, then my negative 12x squared, and then we have a positive 36x. Okay, so we're going to look at this the same way we did the last time. We're going to say, can we pull out a greatest common factor? Well, we can pull out a 3 from each of these, as well as a single x. But again, since our leading coefficient has a negative in front of it, we want to pull that out. So instead of pulling out a positive 3x, let's pull out a negative 3x. And when we do, that's going to leave us with positive x squared, positive 4x, and negative 12. Okay, so from here I'm going to bring my negative 3x down, and since we have a trinomial, right, 3 terms whose leading coefficient is a 1, we're going to open up 2 sets of parentheses. Since x times x gives us x squared, we'll put an x in the first spot in each parenthesis. And then we want to find 2 numbers that add to 4 and multiply to negative 12. So positive 6 and negative 2. So this is, again, factored for us. And remember, whenever you want to check, you always can. All you have to do is just multiply everything, okay? Distribute the negative 3x into the first set of parentheses only, and then take that answer and double distribute it with the x minus 2.